Welcome to OOTO TV, the out-of-the-office investigation from the past into the future of artificial intelligence. This time, we're discussing agentic design principles. I'm Alex, and today we are going way beyond the buzzwords to lay out the actual architect's blueprint for building truly intelligent AI systems. We're talking about a massive shift, moving from AI that can just chat to AI that can actually do.
You know, for the last few years, our main interaction with AI has been pretty conversational, right? We ask a question and it gives us an answer. And don't get me wrong, it's incredible technology, but it's also fundamentally reactive. Well, the entire landscape is now shifting towards something far more powerful: autonomous, goal-oriented agents that can perceive, reason, and take real, concrete actions. The big idea here is to move beyond just writing a clever prompt and start constructing sophisticated systems using a set of proven, reusable design patterns. Think about it like this. It's the difference between a simple calculator that just answers your math problems and a self-driving car that actually perceives the road, plans a route, and actively navigates the world to get you to your destination.
And I'm Ben. In this investigation for OOTO TV, we're going to be exploring a really comprehensive guide based on these established agentic design patterns to see exactly how these complex systems are put together. We'll kick things off with the foundation, what an agent even is. Then we'll get into the exciting part, the cognitive core, how they think and make decisions. From there, we'll look at how they remember, learn, and actually pursue goals. And critically, we're going to spend a good amount of time on the safety rails needed to keep them in check. And then finally, we'll connect all of this technical architecture back to real-world business value and take a peek at what the future holds.
All right, so let's start with the absolute fundamentals. Before we can build a skyscraper, we have to agree on what a brick is, right? So what exactly makes an AI an agent? It's a term that gets thrown around a lot, but in this architectural context, it has a very specific, very crucial meaning.
The two words that really matter here are autonomy and action. See, an agent isn't just a passive library of information like a search engine or a simple chatbot. It has sensors, whether that's reading emails, monitoring stock prices, or literally seeing through a camera to perceive its environment. It has a decision-making process, its cognitive engine, to figure out what that data means. And most importantly, it has tools to take action, like sending an email, buying a stock, or controlling a robotic arm to actively work towards a goal. It's a system with genuine intent.
Okay, Alex, that's a great technical definition, but let's make it really concrete for everyone. How is this different from the AI that most of us are using every single day, like a standard customer service chatbot on a website? Well, a simple chatbot is purely reactive. You ask, it answers. End of story. It's also completely stateless. The second you close that window, it forgets the entire conversation ever happened. It's just following a script. But an AI agent? It's proactive. It doesn't just sit there waiting for your command. It can actually anticipate needs and take initiative based on its goals. It's stateful, which means it remembers past interactions to build context over time. And above all, it's goal-oriented and autonomous, actively trying to accomplish something much bigger than just answering the next question.
Exactly, Ben. And that distinction is the foundation for everything else we're going to talk about. So now that we have a really clear idea of what an agent is, let's pop the hood. How does an agent actually think? Now, this isn't about consciousness or anything like that. It's about pure architecture. We're going to explore the core patterns that make up the agent's cognitive engine. So an agent's thought process isn't some kind of unknowable black box of magic. It's actually a series of structured, repeatable patterns. The most fundamental one is called prompt chaining. Instead of trying to solve a huge, complicated problem with one massive, messy prompt, the agent breaks it down. It deconstructs the request into smaller subtasks, tackles the first piece with a very targeted prompt, and then, and this is the critical part, it uses the output from that first step to intelligently create the prompt for the next step, and so on. It's kind of like an assembly line for reasoning, building a coherent final result from smaller, much more manageable steps.
That makes a lot of sense for a linear process, Alex, but it still feels a bit like a one-track mind. What happens when a task needs different kinds of expertise at the same time? How does an agent handle something truly complex, like putting together a detailed market research report that needs data gathering, writing, and editing all at once? Well, that's where this next pattern, the multi-agent system, becomes so incredibly powerful. It's literally like building a project team of specialized AIs. You've got a coordinator agent acting as the project manager. It assigns a task to a research agent to go out and pull data. That data then gets passed to a writer agent to draft the report. And then crucially, that draft goes to a reviewer agent that checks for quality and accuracy. They can collaborate and pass work back and forth just like a human team would. You're listening to OOTO TV with research by author Paul Bulow. That multi-agent system, Ben, is just one piece of this cognitive puzzle. The real power comes when you start combining it with other patterns. Routing, for instance, acts like a smart switchboard. A request comes in, and the router agent figures out exactly which tool or specialized agent is the best one for the job. Planning is the agent's ability to create a detailed step-by-step roadmap before it even starts working. Tool use is absolutely vital. It's what lets the agent actually interact with the world through other software, like searching a database or booking a flight. And reflection is one of the most advanced. The agent can literally review its own work, spot flaws, and then try again to improve it. That is a huge step towards self-correction.
So we've got this sophisticated cognitive engine built from a whole toolkit of patterns that let it reason, plan, and use tools. But a brain that can't remember or learn isn't really intelligent, is it? It's just a fancy calculator. This next section is where we go from a one-off problem solver to a system that actually has persistence, memory, and a real purpose.
Exactly, Ben. For an agent to be a true partner and not just a gadget, it has to grow from its experiences. This is where three key capabilities come into play. Memory management is about way more than just chat history. It's about creating both short-term memory for the current task and a long-term memory to store and retrieve info and maintain context over weeks or even years. Then you have learning and adaptation, where the agent can actually change its behavior based on feedback, either from a human or just by analyzing its own results. And finally, goal setting and monitoring gives the agent its driving purpose. It knows what it's trying to do, it can track its own progress, and it can adjust its plan on the fly if it hits a snag.
Okay, these capabilities are genuinely transformative. I mean, they take an agent from being a simple reactive tool and turn it into a persistent, evolving partner. But this level of autonomy and learning immediately brings up the most critical question of all. As these systems get more and more capable, the need for safety, for security, for predictability becomes absolutely paramount. So how on earth do we build these things so that we can actually trust them?
And I have to ask this directly, Alex, because it is the question on everyone's mind with this technology. When you have agents that can learn, adapt, and use external tools to take action in the real world, how can we make agentic AI solutions safe and secure? What are the non-negotiable architectural pieces that stop them from going off the rails?
This is easily the most important part of the entire blueprint, Ben, and it's not some optional extra. It has to be baked into the design from day one. You've got exception handling, which is the agent's ability to deal with unexpected errors without just crashing. You have human in the loop, which is absolutely crucial. This is about designing specific checkpoints where a human has to give an explicit thumbs up before a critical action is taken. Guardrails are the hard-coded rules that define the agent's ethical boundaries, things it is simply never allowed to do. And evaluation and monitoring means we are constantly and automatically watching the agent's behavior to catch any problems early on.
And let's talk about one specific, incredibly important technique for safety: grounding the agent in reality. One of the biggest risks with large language models is hallucination, when they just confidently make stuff up. Well, the RAG pattern is a brilliant architectural solution to that. Before the agent generates an answer, it is forced to first go and retrieve relevant information from a trusted, curated knowledge base, like your internal company documents. This grounds its output in facts, dramatically reducing the risk of it inventing answers. It's like telling a student they have to cite their sources for every single claim.
That's fantastic, Alex. These safety patterns really get to the heart of the challenge of real-world deployment. It's one thing to build a cool prototype, but it's another thing entirely to run it reliably in the wild. This brings me to my next big question for our OOTO TV investigation. What are the key elements for Agentic Design to achieve success with deployment and maintenance updates? How do we manage these complex learning systems over the long haul?
That question really gets to the core of operationalizing this tech. And the answer is actually in the very safety patterns we just talked about. They pull double duty. Continuous evaluation and monitoring isn't just for safety. It's the key to successful maintenance. By tracking performance, we know exactly when an agent needs an update. And human in the loop ensures that as we roll out those updates, there's always a layer of human oversight to validate the changes. So these patterns are absolutely essential for long-term management. Now, let's pivot from the technical side to its practical business application.
All right, Alex, we've walked through the whole blueprint. Now it's time for the bottom line. This is clearly complex, so why should a business invest the time and energy to build this way? How can agentic design be a successful method for business solutions? What's the real, tangible value here?
The answer is incredibly powerful, and here's the first key point. Agentic design is a modality to achieve business continuity while achieving rapid growth. Just think about it. You can design autonomous agents to handle core business processes, customer support, inventory management, you name it. As your business scales and the workload explodes, these agents can handle that increased load 24/7 without you needing to hire and train a proportional number of people.
You're listening to OOTO TV with research by author Paul Bilo. On top of that, Agentic Design significantly improves quality and assurance when it's designed as a complete solution. This isn't just about going faster, it's about being more reliable. When you build in patterns like reflection, where an agent critiques its own work, and evaluation, where outcomes are constantly measured, you are literally embedding quality control into the workflow itself. An agentic solution design can achieve success and quality in both small and large projects, precisely because it's inherently self-correcting and built on constant verification.
So the real value isn't in any single one of these patterns, but in how they all work together. And that's exactly why agentic agent delivery is so critical to achieving business goals. It's a complete, integrated approach. You're not just automating one task. You're creating a robust, self-managing system that handles entire workflows with quality control and scalability built right in. The key takeaway really is that these systems aren't just an upgrade, they are a whole new paradigm for autonomous operations and delivery.
That's perfectly put, Ben, and that brings us to the final assembly. We've looked at all the individual components, all the patterns and principles from the ground up. So now let's step back and look at the completed blueprint, the full picture of what we're actually building here.
We started with the basic definition of an agent. From there, we built its cognitive engine with patterns for reasoning, collaboration, and taking action. We gave it persistence and purpose with memory and learning, and then we fortified the entire thing with essential safety protocols like guardrails and human-in-the-loop. What we're left with isn't some simple program, but a complex, interconnected system where the whole is so much greater than the sum of its parts. It really is a new architecture of intelligence, and it's poised to completely redefine how work gets done.
The core message of this entire investigation for OOTO TV is that building powerful, reliable AI agents is a deliberate act of architectural design. It's not about finding one magic prompt. It's about methodically combining these proven patterns to create a system that is capable, robust, and aligned with our goals. The blueprint exists. The tools are here, which leaves all of us with the ultimate question. Now that we have the blueprint, what will we choose to build? For OOTO TV, I'm Ben.
And I'm Alex. Thanks for joining our investigation.